risk should be reduced. It should be identified, and the risk should be analyzed, and then there should be planning, proper planning, how to mitigate it. And it's very important that we have been successful in mitigating some of the major crises. Like in 2019, there was a cyclone, and the early warning system allowed many lives to be saved because they were rescued and they were also shifted to the shelter homes. And in June 2020 also it was done, and almost 1 crore people were evacuated and they were shifted to the shelter homes. So the point is that the early warning system is also very important, but then the workforce, which presently we see NDRF as the main working force, but our volunteers can also be used to strengthen their hands, because it is their primary task, but the volunteers can also help. And it is also very heartening to see that people generally volunteer. Whenever there is a crisis, they generally volunteer. So if they are trained, if they are educated, and if they are exposed to the intricacies of the system, the trained workforce would be much more helpful and productive, and timely information will help to save many lives. So I appreciate the work being done by NIDM, and particularly Professor Surya Prakash has taken so much interest in this initiative that he has roped in almost 11 universities, and I'm really thankful to him for taking this initiative, because disaster is the second part of our life, human life. Like, we are amidst the COVID-19 pandemic, and this also comes under the Disaster Management Act, and all the protocols are being followed as per the disaster. But then again the question comes that how we perceive the threat. And it is as the unlock process is going on, people are thinking that everything has become all right, it has become normal. So now they have also started to change the norms. They are not wearing masks, they are not following the protocol of social distancing, and this is increasing the impact of COVID-19. So I think the training, the awareness, the information, the communication, and the connectivity and collaboration are very important if we want to mitigate disaster, if we want to reduce the risk of disasters, and if we want to prepare people towards adopting good lifestyle, or also to protect the human lives. So once again, I would like to thank the NIDM, and I would also like to thank Harjeet Kaur. She has been speaking to me quite frequently about the systems and about just to remind me that I should be there. And then the moderator, Raju Thapa, although I have not seen him, because I think there is some technical problem from their side and maybe from my side also. But I'm really thankful to NIDM and to Professor Surya Prakash, who has arranged this event very nicely. Thank you so much. Thank you.
Thank you very much. Takeaways point from your address. Thank you for joining us. And now moving ahead, we have with us Professor Saket Kushwaha. He's Vice Chancellor of Rajiv Gandhi University, Arunachal Pradesh, and former VC of Lalit Narayan Mithila University, Bihar. Saket Kushwaha is an Indian education and agriculture economics. Kushwaha has served as the Dean of the School of Management at Federal University of Technology in Nigeria. He also served as a professor at Banaras Hindu University. With these words, I would request Professor Saket Kushwaha for his keynote address. Over to you, sir.
Good morning. Namaste. Suprabhat. I think I'm audible, Madam Harjeet?
Yes, sir. You are audible.
Yeah, thank you. I was just listening carefully the word of wisdom from Professor Nautiyal, madam. She is an energetic colleague, and she is also a lead person in one of the. She is taking up. So, Madam Nautiyal, thank you very much for supporting this program. And Dr. Surya Prakash, very good morning to you and your team. I think nowadays it is worth mentioning, since this National Education Policy 2020 is on board, and we are all very eager to see the changes what we have on ground and how differently it is going to work. I think that is the Madam Harjit, I think there's some disturbance. Hello, Madam Harjit.
Yes, sir. Yes, sir.
There is some disturbance.
Please, my mute mic.
Okay, so let me continue. So I think this is the right time for us to discuss these issues. Very rightly said by earlier speaker.
I will request Professor Arunachal ma'am to kindly log in once again.
I cannot do anything. Mic from my side. Mic is mute. I cannot do anything.
Okay, I think no problem. We can continue like this. This is also one kind of disaster, and we should continue. Well, let me tell you, this is the right time for us to really look into the issues once again. And there are two kind of things I used to teach my student when even in Africa, Nigeria, as well as in BHU, Varanasi. Being a teacher, being a student of agriculture economics, we are teaching risk and uncertainties to the farmers, and how to mitigate them is one of the art of managing farm. So I believe that nowadays it is worth mentioning that all of us at this level, we should also inculcate the habit of learning issues, particularly like I have seen in some of the countries which are these risk-prone countries like Japan and some other countries, where from the childhood age, that means when students are going to the pre-primary schools, that means babysitting just after babysitting era, when they are being told that during these kind of uncertainties, how our young brain must react. And in every class, at every level, we are giving them at that level, we are giving them art of, like we have art of living. So art of managing the risk and uncertainty, and how to involve yourself in disaster management. You see, recently, I think yesterday, day before yesterday, in the night, there was a problem in Bhiwandi, and I was listening to the chief of NDRF, and he spoke well that they are working hard. I think I can continue. Hello.
Please continue, sir.
Yeah. So.
Hello, sir.
Yeah.
I will request Professor Annapurna ma'am to kindly log out and log in once again.
Okay.
Actually, ma'am, we are unable to control your mic.
Even I am also unable to control my mic. I'm leaving.
Is it okay now? Hello.
Yes, sir. Yes, sir.
Yeah. Thank you. And sorry for this kind of thing. And we should not be losing hope when these kind of things are happening. You see, technology failure is part and parcel of life, and that is why I'm telling you that from day one when a child is attaining the age of 4 or 3, then child must be told about few issues. Among those issues, one of the issue I believe that we should teach even a small child how to respect the constitution. A small child of 3 years of age might not know what is constitution, but it is a duty of family members and all those around that child must be able to communicate that this is the document through which we are governing life. Likewise, at the age of 3, we are supposed to inculcate the habit of vibrating the brains of these youngsters, these kids. And Madam Nautiyal was very open and clear. I'm very happy that she spoke on the issues of incorporating these topics. Let me tell you what is happening. Because we were operating using land grant system of education, and many of us they know the system, and now we have new education policy, National Education Policy 2020 on board, and in that policy we have done so many other things, but I'm not going to discuss those things. But where is the confusion? That is very important for us to note. You see, in last 3 years, if you have seen that now there's a course on NCC. There are courses in our PG and UG syllabus addressing the issues of environmental degradation and sustainable development. So the thing is that when you calculate the credit hours to be offered by the student to obtain a degree or to earn a degree, the problem comes that whether he or she at the UG level is going to offer what? One course on environmental development, or one course on NCC, or one course on disaster management. So the problem is that we are unable to kind of convince our young youth brigade, that means those students who are doing UG and PG, that they are supposed to offer more than one course which might be required for them to learn the art of living. When I said art of living, don't misinterpret me from that art of living of Sri Ravi Sankarji, but I'm also close to Sri Ravi Sankarji, so it is worth of mentioning that art of living particularly addresses the problem of handling the issues whenever they arises. Now, what are those issues? One issue is like this during pandemic crisis. What is the basic issues? The discipline, which I feel is one of the basic issues. Even in when NDRF is trying to operate on one of the project, the basic thing is that the number of people present on the ground who are unable to assist, even if they wish to assist, but the protocols they are not being told. And take the example of Bhivandi building. Suppose all these 2,000, 3,000, 5,000 people in the name of helping those people who are buried under debris, and they start climbing on the broken structure, then you know what is going to happen? Because if there is of operating within this kind of system, so maybe building will collapse more, or maybe there is a little space for breathing, and because we are matching on the ground, the dust and other debris will enter in that hole, and then it will block the oxygen supply. So there's a need for us to educate the larger society to handle the issue of all kind of disaster. And let me tell you, disaster is sometimes man-made also. The way we are involved in the deforestation of in our country, in the name of some activities or in the name of some business, commerce, the issues are increasing multifold. Let me tell you, about 3 or 4 days ago, there was a landslide in Arunachal Pradesh, and I think that it was also in the news Now I'm a live witness of all these landslides. I was traveling from Itanagar to Tawang area, and there we saw a lot of landslides. And it was, I would not say I was fortunate, because immediately when I passed through that road, one of the jeep was involved in the landslide, and I think 7 or 8 people died. I was not too happy from seeing these kind of things. So the problem is that in Arunachal Pradesh, the way NDRF has operated, I think that Dr. Kurtaras was with me in my office, and I really wish to suggest Dr. Suryaprakash that if somehow not you alone, or the vice chancellor and maybe educationists involved in the system, if they can suggest a kind of course every semester for PG at the likewise one course. Hello. I'm cracking. Do you think I'm cracking?
Sir, your voice is breaking, sir.
Should I rejoin myself again? That is the voice is breaking.
Hello, sir. Hello, sir. Sir, we are unable to understand, sir.
Sir, if you can, it will be fine. Sir, if you can rejoin, then it will be better.
Hello?
Sorry for the inconvenience, as all we understand that due to some technological errors, there is some issues, and we can understand that Kushwaha sir is joining from Arunachal Pradesh. That area is more vulnerable and hilly area of our country, so we can understand this type of problem. So meanwhile, I'll move ahead and do my felicitations address. First of all, I would like to express my utmost gratitude to Major General Manoj Kumar Bindal, VSM Executive Director, NIDM Professor, Annapurna Nautiyal, Vice Chancellor, Hemvati Nanda Bahuguna, Garhwal University, and Professor Saket Kushwaha, Vice Chancellor, Rajiv Gandhi University, Arunachal Pradesh, for supporting the collaboration of the Central University of India, promoting capacity development in disaster management. I must also congratulate Dr. Surya Prakash, Head GMR Division, NIDM, and faculties of Rajiv Gandhi University and HNB Garhwal University for coordinating and participating in 5 days faculty development program on disaster management. Taking forward the PM 10-point agenda for achievement of targets set under the Sendai framework for disaster risk reduction, the plan has also focused on achieving a coherence with other international agreements such as Sustainable Development Goals and climate change. The period of these agreements coincide with the SFDRR. So this coherence will result in ensuring sustainable and climate resilient development that will ultimately reduce disaster risk. And it is imperative to mainstream disaster management in education sector and to adopt an inclusive approach towards risk reduction to ensure sustainability of development initiative and to widen its reach to cover every citizen. So I hope all the participants will have some takeaways point from this training program. So I request our moderator, Mr. Raju Thapa, to take over the technical session. Over to you, sir.
Yeah, Harjit, can I leave now?
Yes, ma'am.
Yeah, just 1 minute. I would like to just correct you that the name of my university is Hemvati Nandan Bahuguna Garhwal University, right?
Oh, yes. Sorry, ma'am.
HNB HNB Garhwal University, and my name is Annapurna Nautiyal, right? Okay.
Yes.
Okay. Thank you so much. Thank you.
Thank you, ma'am. Thank you, ma'am, for being
Thank you
here.
so much. And thank you for the inconvenience because nothing was in my control. Everything went ahead.
It's okay.
So I do not know what happened. Okay.
Yes, ma'am.
Anyways, thank you
Yes,
so
ma'am.
much. Thank you. Thank you.
Thank you, ma'am. And for all participants, I am extremely sorry for the technical glitches that occurred in the inaugural session. With that, we have come to the end of the inaugural session. Now we're moving on to our technical session. We have very senior level resource person, experts who have very long, meaningful experience on the subject. And in this technical session, there will be presentation, and after each presentation, there will be question and answer sessions. Please raise your question in question and answer window only. Participation is very important to us. You can ask your question in question and answer chat box window. One more important announcement that participants have need to have 80% attendance in Cisco WebEx event in all the 5 days of the training. And the same link that you use today to join the program will be used for all the 5 days of the training program. So now for our first presentation, we have Mrityunjay Mahapatra ji, Director General of Meteorology, India Meteorological Department, Government of India. Dr. Mahapatra ji has vast research experience on weather forecasting and cyclone warning, cyclone disturbance, monsoon low pressure system, heavy rainfall, thunderstorm forecast verification, etc. Dr. Mahapatra is recipient Chintamani Memorial Medal, Commendation Certificate during 1989 from Defense Research and Development Organization, Ministry of Defense, Government of India, significant contribution to integrate the Guided Missile Development Program. And he is also recipient of Certificate of Merit for Young Scientists 2008 by Ministry of Earth Science, Government of India, and many more. I would like to also inform you that Dr. Mrityunjay Mahapatra, who is affectionately known as the Cyclone Man of India, for having accurately predicted the path of furious cyclone storm Phelan that hit the coast of
I request Dr. Mrityunjay Mahapatra for his presentation.
Okay, so thank you. Good morning, namaskar. So at the outset, I congratulate ED, NIDM, Vindal Saab and his entire team for organizing this training program for the teachers. And also I am thankful for giving an opportunity to speak in this important training program. Am I audible, madam?
You are audible plus your PPT is visible.
Fine, thank you. So I'll proceed now. So I have been allotted to talk about cyclone and its forecasting. So my PPT is moving. Are you able to see the second slide?
Yes, sir. Yes,
Yes,
sir. We can see.
Okay, thank you. So I will just begin with what a cyclone is. As all of us know, in layman's term, when there is a cyclone crossing a coast, you will find that there is torrential rain, heavy rainfall, continuous rainfall, or you can say downpour. And also you will find that there is strong wind, trees are uprooted, tree branches are cut off, you'll find that houses are damaged. Also you'll find that sometimes the saline water from the sea is inundating. So we understand the tropical cyclone in terms of, therefore, the associated severe weather like heavy rainfall, winds, and storm surges. Storm surge is nothing but the tidal wave which inundates the low-lying areas when a cyclone crosses the coast. The important point is that when a cyclone is crossing the coast, all these three, heavy rainfall, strong wind, and storm surge occur at the same time. So therefore, cyclone becomes a multi-hazard scenario. It causes the damages because of the storm surge in terms of flooding of coastal areas, erosion of beaches, loss of soil fertility due to saline intrusions, and also it can cause damage to structures in the coastal areas. Similarly, wind also can cause damage to structures. There can be loss of power and communications. There can be injuries and loss of lives. There can also destruction of crops, vegetation, livestock. The rainfall associated with cyclone causes contamination of water, supply system, land subsidence, flooding of inland areas. So all these three are occurring at the same time. So therefore, the cyclone is considered as a killer. So if you just look at a few facts about the cyclones, you will find that about 33% of the total hydrometeorological disasters are caused by tropical cyclones during this latest period of 1970 to 2019. 1 out of 3 events that killed most people globally is the tropical cyclone. TC stands for tropical cyclone. And 7 out of 10 disasters that caused the biggest economic losses in the world during this period of 1970 to 2019 are the tropical cyclones. And you will find that about 85 countries in the world are affected by the tropical cyclones. There could be as high as 300,000 or 3 lakh people deaths in Bangladesh cyclone 1970. It is popularly called as Bhola cyclone because it crossed Bangladesh coast near Bhola. And it is still ranked as the biggest casualty in the last 5 decades due to the tropical cyclones. So therefore, throughout the world, the scientists have tried to have as accurate as possible the cyclone monitoring, cyclone forecasting, and cyclone warning services. And also, all the meteorological agencies try to apply all the available modern technologies for these operational services so as to minimize the loss of life and property. Now, if you look at India, in India, both west coast and east coast are prone for cyclones. Entire west Indian coast are prone for cyclones. But however, this degree of proneness is different for different coastal belts. In this diagram, you can find out that there are certain areas where you got red. Red means it is very highly prone for tropical cyclone activity. Then is the blue, the next is the high prone. Then green is the moderately prone, and the yellow is the low prone districts for the cyclones. So from this, you can find out that east coast is more prone for the tropical cyclones than the west coast. In the west coast, Gujarat is most prone, and the east coast, you will find that Andhra Pradesh, Odisha, West Bengal are more prone. Now, if you look at the cyclone forecasting so far, you will be happy to know that in recent years, we have been able to provide accurate forecast for tropical cyclone tracks and their intensity. As a result, the number of deaths has been reduced. And if you compare our forecast accuracy with the international agencies, you will find that our forecast is at par or better than many leading centers of the world. So this forecast accuracy is increasing every year. As you know, as it was being told that in the recent years, you have seen the cyclone Phylline, Hudud, Titli, Fani, Ampan, where IMD has provided very accurate forecast and thus enabled the disaster managers, stakeholders, and general public to take necessary actions to minimize the loss of lives and properties. So it is to just show you that how many people have died in recent years. If you compare, you will see in different cyclones which have crossed Indian coast, the number of deaths have never exceeded 100. It is limited within 100. At the same time, if you compare the Odisha super cyclone in 1999, there are about 10,000 deaths. So this has been the achievement in recent years in terms of minimizing the loss of lives due to cyclones. So it has been possible because of many initiatives taken by Government of India and the states. It has been an integrated effort by enhancing the technology, by enhancing the preparedness and planning measures, and by enhancing the response mechanism of people, disaster managers, and various stakeholders. So you may think about how did it happen actually, how this changeover or how this game changer happened so that you have come down from 10,000 to less than 100 in terms of loss of lives due to cyclones. I just want to mention here that after Odisha super cyclone 1999, there was even try across the country how to tackle these cyclones which are causing the number of deaths. Then at the central level, Government of India took off a project called National Cyclone Risk Mitigation Project, and it was taken up in 2006. And in that project, IMD was a partner to improve the early warning system. But however, in the same year, Government of India decided to come up with the establishment of Ministry of Earth Sciences. And under the Ministry of Earth Sciences, the modernization program of IMD was taken up. And then IMD decided to modernize its cyclone warning system through its own modernization program. And hence we came out of the World Bank project, that is NCRMP, and this modernization program was taken up. And I was monitoring this cyclone modernization project as project director and also as associate project director for improvement of weather forecasting in IMD. So during this project implementation, we addressed all the aspects of cyclone warning systems for its modernization. Now, with this some kind of background, I will come up with what a cyclone is. Technically, a cyclone does not form from a blue sky. Just we say a bolt from the blue, that does not occur like that. A thunderstorm, you can find out with a blue sky, after half an hour, you will find that there is a thunderstorm. But in case of cyclone, it does not happen like that. A cyclone develops from a low pressure area, and that low pressure area gradually intensifies and becomes a cyclone in a favorable environment. So to define a cyclone, we say a cyclone is a weather system which is called as a low pressure system, where the wind rotates anti-clockwise direction in northern hemisphere and clockwise direction in southern hemisphere. And the minimum wind speed becomes 34 knots or 62 kilometers per hour. So this is the quantitative definition. World Meteorological Organization, which coordinates the meteorological activity among the countries in the world, defines it as a tropical cyclone, a synoptic scale system. All the weather systems are divided into 4 categories. One is called as planetary scale system, which has got the size of more than 1,000 kilometers. For example, monsoon, southwest monsoon is a system which is a planetary scale system because it extends from USA to Japan. So we say it is a planetary scale system. A tropical cyclone is a synoptic scale system. This system is having the size of 100 kilometers to 1,000 kilometers. So low pressure depressions, cyclones are the synoptic scale systems. Similarly, the thunderstorms are called as the mesoscale systems with size of 10 kilometers to 100 kilometers. Then there is another system called as microscale systems like tornado, water spouts. So these are called as microscale systems. So considering these, the spatial dimension of the weather systems, they are divided into 4 categories. And cyclone comes under the category of synoptic scale systems. And it is a non-frontal disturbance. So if you look at the weather systems in the USA, UK, or European countries, you will find that there the systems forms because of the difference in temperature. So the temperature plays a dominant role, and that temperature comes as a cold front or warm front. With those frontal systems, also sometimes cyclones form, but those cyclones are not tropical cyclones. They are called extratropical cyclones. They are not dangerous. The tropical cyclones are dangerous systems. So these tropical cyclones are not frontal systems. These are non-frontal systems. They develop over the tropical water. When I say tropical water, as per our geography, from equator to 23.5 degree north and south is called as the tropical region. So generally, these cyclones develop within these tropical belts and further over the tropical water. Because formation of cyclone depends upon the amount of moisture available, amount of energy available from the sea. And then other thing is that in a tropical cyclone, the cloud, which is developed because of the convective process in the atmosphere, is highly organized cloud. There is a definite cyclonic surface wind circulation. So when I say convective cloud, I want to say that, as I told you, this is a process in which heat energy is transferred. The heat energy can be transferred from one place to another place in three ways: the conduction, convection, and radiation. Among these three processes, in the weather systems, convection plays a dominant role. Just like boiling the rice in a bowl, in the atmosphere, when there is a heating from the surface, from the sea surface or the land surface, the particles get heated and they move up and down. Through this movement of the particles, heat energy is transferred from one layer to the other layer. So this process of transfer of heat energy is called as convection. And this convection process leads to formation of the clouds, especially the thunderstorm clouds and highly rainfall causing clouds. So therefore, a tropical cyclone is a convective system. Tropical system is a system developing over the tropical area. It is a non-frontal system, and it is a system in the size of 100 kilometers to 1,000 kilometers. It is a system where clouds are highly organized. It is a system where winds are rotating anti-clockwise in northern hemisphere and clockwise in the southern hemisphere around the center of the low pressure systems. And the minimum wind speed is 34 nautical miles per hour or 62 kilometers per hour. 1 nautical miles per hour is equal to 1.85 kilometers per hour. Now, these tropical cyclones, though mechanism is almost same throughout the world with little difference, they are called with different names. Over the Pacific area, they are called as typhoons. Over Australia, they are called as willy willies. In Mexico, they call it coranzo. Philippines, they call it dajas. In Indian Ocean, we call it cyclones. In Atlantic and Eastern Pacific, they are called as hurricanes. Now, if we look at the structure of a tropical cyclone, you'll find that on the left-hand side, you can see the diagram. And here in this diagram, you will find that there are 4 parts in a tropical cyclone. This is a satellite image of the tropical cyclone. In the central part, you will find that there is somewhat an elliptical or circular structure where you find the dark color. Dark color means there is no cloud. White color means there is cloud. More the whiteness, more depth is the cloud. So in this picture, you will find that in the center, there is a region which is circular elliptical, and its diameter is about 10 to 100 kilometers. You have the cloud-free region. So this cloud-free region at the center of the cyclone is called as eye of the cyclones. Eye is circular elliptical. Eye may be regular. Eye may be rocked also. If eye is sharp, eye is smaller, and eye is circular, it is more intense cyclone. And surrounding the eye, you will find that there is a region where we have got very deep convective clouds surrounding this eye, just like they are just guarding the eye of the cyclones. This is called as eye wall. So eye wall is a very strong convective cloud zone. And this is also circular, and its width can be about 100 kilometers. And this eye wall region is the region where you will have the maximum winds, where you will have the maximum rainfall. So therefore, this eye wall region is the most disastrous region. So maximum rainfall occurs and maximum wind occurs in this region. Then you will find that just like coiling or spiraling of our notebooks for the students, you will find that the cloud mass is just spiraling from outside towards the center. So this is one spiral coming from outside and going towards the center. This is another spiral coming from outside going towards the center. So these are called as the spiral bands. These spiral bands are also dangerous bands, or rainfall occurs, winds also occur. But as you go away from the center along the spiral band, the convective cloud gradually decreases and also the rainfall decreases. So therefore, towards the center along the spiral band, you will have higher rainfall and higher wind. As you go away from the center, the rainfall and wind decreases. Then you will find that just at the outskirts, sometimes there can be some kind of convective clouds that is called as outer layer of the cyclones. So this is a system, is a vast system, as you can see. It has got a height of about 10 to 15 kilometers. The horizontal dimension is about 100 to 1000 kilometers. And it moves with a speed of about 300 kilometers per day. So people get confused on these two parameters. One is the wind speed associated with the cyclone. Other one is the speed by which cyclone is moving forward. The cyclone moves usually with a speed of 300 kilometers per day. So, but the wind speed associated with a cyclone can be as high as 300 kilometers per hour. So this is two different things. So therefore, if I calculate what is the winds, what is the speed of a cyclone per hour, it may be about 15 kilometers. 15 kilometers per hour, it moves. But whereas the speed associated, wind speed associated is can be in such a cyclone, super cyclone is more than 260 kilometers per hour or 200 per hour. It can be. So with this background of the structure spatially, let us look at the definitions or categorizations. As I told you, the cyclone develops from a low pressure area, and when it is a low pressure area, the wind speed associated is less than 31 kilometers per hour. When it is a depression, it intensifies. If all our basic parameters are favorable in the environment, a low intensifies becomes a depression. The wind speed associated will become 31 to 49 kilometers per hour. And a deep depression, the wind speed becomes 50 to 61 kilometers per hour. The cyclone storm, wind speed becomes 62 to 88 kilometers per hour. Like this, the wind speed increases, and severe cyclone storm wind speed is 89 to 117 kilometers per hour. In a super cyclone storm, wind speed is 222 kilometers per hour or more. So how does it happen actually? When a cyclone, when a low pressure area is there, you have got the lowest pressure at the center, you have got higher pressure outside. So as a basic principle, if there is a low pressure, there is another high pressure, wind blows from high pressure to the low pressure. As the wind blows from high pressure to the low pressure, because of the Coriolis force, this wind gets deflected and it rotates anti-clockwise in northern hemisphere and clockwise in southern hemisphere, and in a rotational manner it goes towards the center of that low pressure. So therefore, when there is a low pressure system, you get rotational wind, and this speed of the wind will gradually increase if the depth of pressure fall at the center of the low will go on increasing. So by that way, the speed increases and hence the intensity of the cyclone or system increases. Now, if you just look at the radar picture, so we have come a long way with respect to radar monitoring of the cyclones. On the left-hand side, you will find that this picture is a picture of the analog radar. So with the analog radar, we are monitoring from 1974 onwards. The cyclones were being monitored along the coast with the analog radar. Here you can find out that at the center there is a dark region. This is called the eye of the cyclone, as seen on radar. Surrounding that, you have got this dense convective cloud, which is called wall cloud or eye wall. Surrounding that, again, you are finding some kind of dark region here. This is also another eye. So what happens actually in this particular cyclone, there are two eyes. This is the inner eye. This is called as outer eye. This is the inner eye wall. This is called as outer eye wall. So it sometimes happens. But in our area, these double eye wall structure cyclones are very rare, but still it occurs. You can find out such type of double eye wall structure cyclones. In recent time, it has occurred with the cyclone Phylline. Also, it has occurred with super cyclone 1999. So that was analog radar, where you can find out only convective clouds. You can find out these structures. But in recently, starting from 2006, we got the Doppler weather radar. This is the right-hand side picture. You will find that here also, this is the eye of the cyclone. This is the wall cloud region. These are the spiral bands. So you can find out more in detail with respect to. But apart from that, in Doppler radar, you can find out the wind due to the cyclones also. Wind distribution can be found out. Not only that, you can also estimate what is the amount of rainfall associated with the cyclone at a particular time. So since the data from the Doppler radar is digital, this data also can be utilized in models to provide the forecast. So therefore, Doppler radar has become very highly useful as compared to the analog radar which were being used earlier. So now if I look at how a low pressure becomes a cyclone, you can see this picture on the top, you will find that of left. This is a picture of just a low pressure area where you will find that these convective clouds are just scattered. There is no organization of the convective clouds. But in this picture, you will find that convective clouds are getting clustered, they are getting organized. Now this is a depression. So this is the difference between low pressure, it is a depression. Now further concentration of the convective clouds continues and becomes a cyclone. This is the picture of a cyclone. And further, the cyclone also organizes, giving the ice structure, it becomes a very severe cyclonic storm. So this is the evolution you can see in a satellite picture, how a low pressure area converts into a depression, then into cyclonic storm, then into a severe cyclonic storm or very severe cyclonic storm. Now, if you look at the life cycle of a cyclone, you'll find that in general, a cyclone has got a life period of about 5 to 7 days. In Indian Ocean region, that is Bay of Bengal and Arabian Sea, average life period is about 5 days. During these 5 days, there are 4 stages of the cyclone. The first stage is formative stage, second stage is immature stage, or you can say growing stage, third stage is mature stage, and fourth stage is decaying stage of the cyclone. So in the formative stage, which is also called as the cyclogenesis, the genesis is taking place. And at that time, what happens actually, a low pressure area converts into a depression. We say a cyclogenesis has occurred over Bay of Bengal or Arabian Sea if a depression forms. With the formation of depression, it is called as cyclogenesis throughout the world. So that formation of depression, from low pressure area to depression, it can occur within a few days. Usually, in 3 days, we get the conversion of low pressure into a depression. But sometimes it can happen in 1 day also. There is a rapid intensification. Low pressure can become a depression within a day. But usually it takes about 3 days, the low pressure to become a depression. And what happens actually in this formative stage, the pressure falls at the center of the low pressure systems compared to the surrounding, and hence the pressure difference between the high pressure and low pressure increases, and hence the wind blows strongly, wind speed gradually increases. So this procedure continues in the immature stage. When it becomes depression to deep depression, then cyclones and severe cyclones, it goes on increasing. That is called immature stage. In this immature stage, wind speed goes on decreasing, the pressure at the center goes on increasing, and organization of the clouds goes on increasing, and size of the cyclone also goes on increasing. Then comes the mature stage, where no further increase in intensity occurs. The central pressure becomes constant, the pressure wind associated with the cyclone becomes constant, but at that time, size of the cyclone also can increase. So in the mature stage, while the pressure and wind remains same, the size of the cyclone can even go on increasing. Then comes the decay of the system. The cyclone decays after attaining the mature stage. When the cyclone decays, the central pressure increases, the wind speed also decreases, and gradually the clouds get disorganized and it dissipates. Now, this decay can occur due to various reasons. The decay usually occurs when the cyclone moves to the land surface. Because as the cyclone moves to land surface, it does not get the moisture from the sea, and hence the convective cloud cannot sustain. It rains also, therefore it weakens. Otherwise, when the cyclone moves in the colder area of the sea, if sea is colder, it cannot provide the heat energy. So therefore also the cyclone weakens. Also cyclone can weaken if it moves into an area where your environment is not favorable. For example, if there is a wind shear in the environment, that means wind is increasing with the height, then also it will weaken. Also, it happens sometimes if there are two cyclones and they are coming closer to each other. If one cyclone strengthens, other cyclone weakens. If one cyclone weakens, other cyclone strengthens. So this is called as the Fujiwara effect. Because of that, also cyclone can weaken. So now I'll just discuss about the movement and the vertical extension of the cyclones. If you look at this picture on the left-hand side, you will find that this is how the wind rotates around the center of the cyclones. Just see, it is rotating in anti-clockwise direction. It is in the Bay of Bengal near Andaman Islands. It is located here. Now, cyclone is moving towards northwest. As it moves, accordingly, winds also rotates and goes on shifting from one place to the other place. What you find actually, the cyclone movement is usually towards northwest direction. Because of the rotation of the earth, the cyclone usually moves in northwest direction. So therefore, if any cyclone develops over the Bay of Bengal, usually it develops near Andaman Sea or southeast Bay of Bengal, it has to move towards Andhra Pradesh coast or Odisha coast. So that is the reason why among the states in east coast, Andhra and Odisha are most prone for the cyclone activities because of this climatological movement of the cyclones. But cyclones do not move always in northwest direction. Because of the atmospheric parameters, it can change its direction of movement and it can recurve or change the direction and move towards Bangladesh, Myanmar, or West Bengal, and also it can move towards Tamil Nadu or Pondicherry. So there are various factors to determine. But however, you can just see in this diagram, the second one, that how the wind rotates around its center. And as you see near the center, winds are stronger. As you go away, winds are weaker. But in the eye, wind is also light. There is light wind in the eye. There is no clouds and there is no rainfall. If you are in the daytime, you can find out the sunshine if you are located in the eye of the cyclones. If it is nighttime, you can see the stars. So sometimes what happens when a cyclone is crossing the coast, eye is passing through a particular city, for example, Visakhapatnam. Then in the advent of the cyclone, there will be continuous rainfall, continuous wind, there will be damage, devastation. Then after some time, you'll find that all of a sudden wind stopped, rain stopped. If daytime, you will find the sunlight. You will feel that cyclone has gone. But actually, no, cyclone has not gone. Center of the cyclone has come down to your city or village. It is passing through. As the diameter of the cyclone is about 10 to 100 kilometers, it may take 1 hour or 1.5 hours or 2 hours to pass on. And after that, again, you will find that wind direction will change. If there will be very strong wind, again damage, people feel that another cyclone has come. No, it is not another cyclone. It is the rear side of the cyclone, which is approached now, and it is the same cyclone. And it becomes more devastating in the rear side sometimes. So therefore, people should be aware that when the eye is passing over a region or center is passing over a region, there the devastation will occur twice, and that region will be highly affected compared to the other regions. Now, in the below diagram, you find that how the winds are rotating and going up, and it is just like this structure. This is another structure where you will find that this, with the help of this rotating wind, you will find different types of clouds. Near the wall cloud region, the cloud depth is quite high. As you go away, the cloud depth gradually decreases. And you will find that how strongly winds are rotating here and how winds are going up, and they are diverging at the upper level. There is a highly converging wind at the lower level and highly diverging wind at the upper level. You just imagine there is a pipe. If you are forcing water from one end, the outlet of the pipe should be open so that water can flow. So inlet and outlet both are open means water can flow. If you close the outlet, the pipe will burst. The water cannot flow. Similarly here, in the lower level of the cyclone, there is inflow of the winds. And the upper level, there is outflow of the winds so that wind can go off. So this is called as flow of continuity or equation of continuity. So that should have continuity, and that way supported you have the convergence in lower levels, that is inflow layer, and your divergence in the upper layer. So therefore, if you look at the vertical structure of the cyclone, you will find that there are three layers. That is the bottom layer, which is called as the inflow layer. In the inflow layer, the winds rotate predominantly and it moves towards the center. There is convergence of air. Then you will find there is a middle layer where this convergence gradually decreases and divergence gradually increases. So therefore, you can say there is net convergence, net divergence, 0. And the upper layer, you will find that there is completely divergence of wind. Wind is going away, going out of the cyclone field. So this inflow layer extends up to about a 3-kilometer height. And strongest wind occurs at about a height of 1 kilometer. It is because in the lower level atmosphere, near the surface of the earth, there is friction. There are many land surface processes. So therefore, wind speed decreases at the surface of the earth. But if you go to a height of about 1 kilometer, wind gradually increases and becomes maximum. So maximum wind occurs at a height of 1 kilometer. Therefore, if a person is staying in the ground floor, another person is staying in the 10th floor of a multi-storied building, the person staying in 10th floor will experience more wind than the ground floor person. Now, if you just look at the middle layer, yes, in the middle layer, you have got weak inflow, and it extends up to 3 kilometers to about 7.6 kilometers. And outflow layer starts from 7.6 kilometers, and it goes about 12 kilometers or 5 kilometers. And the size gradually decreases as you go towards the top. And if I just consider what is the wind distribution in a cyclone, you'll find that in the eye, wind is very calm or light wind, and wind is maximum on the right side and left side in the wall cloud region, and then gradually wind decreases as you go away. This is the blue line, is the wind distribution in a cyclone. The lowest wind at the center of the cyclone, maximum wind in the eye wall region, and gradually wind decreases as you go away from the eye wall region. Then, of course, pressure, if you just look at, pressure is minimum at the center of the cyclone, and it gradually increases as you go away, this red line, from the center of the cyclone towards the outer layer. Now, this is the vertical structure. If you just look at, as I was telling, that wind is maximum at a height of, this is the vertical structure of the wind. Wind is maximum at a height of about 1 kilometer. This is the wind distribution. And you can find that wind is minimum here, wind is maximum here in the wall cloud region. And also wind speed gradually decreases as you go up to different heights. And eye also, if you see, eye is smaller in diameter here. As you go up, you'll find that eye diameter increases, just like it becomes a funnel type at the center of the cyclones. It is shorter diameter in the lower level and diameter is bigger in the upper level. On the right side diagram, this is the temperature distribution. So you will find that the center of the cyclone is warmer. It is really a very pleasant information that center of the cyclone is warmer than its surrounding region. And this warming increases as the cyclone intensity increases. So therefore, if you are able to measure the temperature at the center of the cyclones, especially at a height of about 9 to 10 kilometers, you can guess or you can predict what will be the intensification of the cyclones. Okay, so this one I have discussed earlier, the double eye wall structure. You can have two eye walls, that is inner eye wall and outer eye wall. You can have two eyes, that is inner eye and outer eye. I am not discussing further here. Now, I just want to explain you that the tropical cyclones are different from extratropical cyclones. The tropical cyclones occur in tropical region, where the extratropical cyclones are occurring in mid latitude. So as I told you, USA, UK, sometimes northern part, they are affected by the extratropical cyclones. In this picture, you can find the left-hand side is an extratropical cyclone, the right-hand side is a tropical cyclone. Their genesis is different. The tropical cyclone occurs because of the convective process, the warm sea, whereas extratropical cyclone occurs because of the frontal system, because of the temperature difference horizontally from one place to another. In the tropical cyclones, winds are maximum at the surface or the lower level of the atmosphere. So therefore, tropical cyclones are highly dangerous. They cause damage to structures. They kill people. Whereas in extratropical cyclones, winds are maximum in the upper level at a height of about 8 to 12 kilometers. So therefore, extratropical cyclones are not dangerous at the surface. They will be dangerous for the aircrafts flying at the height of 8 to 12 kilometers. Similarly, people also get confused sometimes the tornado and the tropical cyclone. On the left-hand side diagram, you can find out this funnel type structure. So this is called as tornado. The tornado, as I was telling in the beginning, is a micro scale weather system which has got a size of about 1 kilometer or less. Sometimes it affects 1 or 2 villages, or 3 villages, or 4 villages. But it has got the same strong wind as you can find in case of a tropical cyclone. Wind can go up to 300 kilometers per hour in a tornado. But what happens in case of tornado, actually, the winds rotate just like a cyclone, it is rotating in anti-clockwise direction, but wind is also very strong vertically. So therefore, in a tornado, the heavy bodies like cars, buses, or trees, they are uplifted and thrown away somewhere else because of the strong vertical wind in the tornado, which doesn't occur in case of a cyclone. But there are certain cases, the cyclone can be associated with tornado sometimes. In wall cloud region of the cyclone, sometimes you can find out tornado, embedded tornado, and that also causes that type of structures. When this tornado occurs over the sea area or water bodies, it is called as water spout. And in that case, it is sucking the atmosphere, therefore the water is sucked off. And along with the water also, fish also can go up and they are scattered outside. So we can find in the childhood or sometimes if you are in the coastal area, that you will find in your yard the fish. How does that fish come here in the rain? It occurs due to this principle of water spouts. Okay, so to define the difference, the tornado or water spouts have a very small diameter. It affects only a few villages sometimes, whereas tropical cyclones can have the effect over a number of states, a number of countries. For example, if you look at Amphan cyclone here, it affected West Bengal, it affected Bangladesh, it affected Myanmar in terms of rainfall. So therefore, the cyclone is a large scale system, whereas tornado is a very small scale system. Now, if you look at the climatology of the cyclones, how many cyclones develop in the world? You will find that 80 cyclones develop in the world in a year, about 80 cyclones. And out of this 80, about 35 becomes very severe cyclones in the world. If you consider our basin, the Bay of Bengal and Arabian Sea, you can find out here, there are only about 5 cyclones per year, and out of 5, 3 becomes the severe cyclones. So if I calculate the percentage, only about 7% of total frequency of cyclones occurring in the world occur in our area. But notoriously, as you have seen earlier, the number of deaths due to tropical cyclones earlier was quite high in this region because of the socio-economic conditions, because of the lack of technology, etc. But in recent years, the number of deaths have decreased, and we have been at par with other countries to minimize the loss of lives due to the cyclones. And if you see different ocean basins, you find that maximum number of cyclones occurs over the Northwest Pacific. It is followed by the North Atlantic and East Pacific. The South Atlantic does not get any cyclones. And our region gets only about 5 cyclones. Now, to look into further in our region, you'll find that out of the 2 ocean basins like Bay of Bengal and Arabian Sea, Bay of Bengal is more prone for cyclone activity than Arabian Sea. It is mainly because of 2 reasons. One is that it is a warmer sea, and also second reason that many of the cyclones which develop over the South China Sea, their remnants enter into the Andaman Sea and they intensify here and become the cyclones also. So because of these 2 reasons, Bay of Bengal gets more cyclones. Whereas the remnants from Bay of Bengal very rarely go to Arabian Sea, and there also they get intensified very rarely. Therefore, the mechanism of remnants going from Pacific to Bay of Bengal does not work from Bay of Bengal to Arabian Sea. So you'll find that out of 5 cyclones, 4 develop over Bay of Bengal and 1 develop over the Arabian Sea. And if you consider the different seasons, we have got 2 seasons: post-monsoon season, October to December, and pre-monsoon season, that is April to June. These 2 seasons, we have the cyclones in our region. This is also another characteristic feature of our region. Unlike other ocean basins, this ocean basin experiences 2 cyclone seasons. Others experience 1 cyclone season only. Okay, so among the months, if you just look at May and November, are the 2 most important months for the cyclone activity in our area. Now, if you look at the genesis parameter, why cyclone occurs? The cyclone occurs basically because of the 6 parameters. The one parameter is the thermal parameter, other one is the dynamical parameter, thermal potential, dynamic potential. Thermal potential says that we should have higher ocean heat content. That means ocean should be hot. Then we should have high humidity in the atmosphere, especially in the middle troposphere. Then we should have unstable atmosphere. Dynamically, it says that we should have the favorable Coriolis force or Coriolis parameter. I will say, because of the rotation of the Earth around its own axis, an apparent force develops. That apparent force is called as Coriolis force. And this Coriolis force is nothing but a deflecting force. I'll take an example. If you put a globe fixed and ask a child to draw a line from equator to the pole, he can draw a straight line with the chalk. Now you ask the same child to rotate the globe from west to east and ask him or her to draw the same line from equator to pole. You will find that the child cannot draw the straight line. That line will be deflected towards the right in the northern hemisphere, and that line will be deflected towards the left in the southern hemisphere. And certainly there has been no extra force applied here. And we know as per Newton's law, if there is no extra force, the body at rest continues to be at rest, body in motion continues to be in motion. State law of inertia. So then why the direction changed? The direction changed because there is a force here. And that force, which is not visible, is called as the apparent force. And this apparent force was defined by Coriolis, and this is called as Coriolis force. And this Coriolis force depends upon the latitude of the place. If the latitude increases, the Coriolis force increases. That means near the equator, Coriolis force is 0. Near the pole, Coriolis force is maximum. So therefore, if you want to rotate the particle air particle or air parcel for the cyclones, there should be the minimum Coriolis force. And that minimum Coriolis force is available from 5 degree north to the north. Within the region from equator to 5 degree north, the available Coriolis force is not sufficient to develop a cyclone. Therefore, cyclone does not develop near the equator. So therefore, it is written that the genesis to take place to the north of 5 degree north. Then relative vorticity. When I say relative vorticity, it is the rotating power. Say, I'll just give an example of rotating top. As a child, we played the top. The top rotates around its own axis. Now, by the way it rotates, that is measured by a quantity called as the vorticity. And the mathematical term is called as del cross V. V is the velocity. It is a vector. So it's a measure of rotation. So the atmosphere should have the rotating power. Higher the rotating power, more possibility will be the development of cyclones. Then other one is the vertical wind shear. Vertical wind shear, I'll just explain like this, that the difference of wind in lower level and the atmosphere and the upper level. If the difference of wind is less in lower level and upper level, then it will be favorable for cyclogenesis. If the difference is high, it will not be favorable for cyclogenesis. Just like this, if I am walking in a windy day with an umbrella, my umbrella will not remain straight because of the high wind, but my feet is not affected. So what happens actually, my umbrella gets bent. Or simply, I will take another example. If you are putting hair, that the hair gets distorted, gets sheared towards direction of wind if there is a windy day. So therefore, in the atmosphere, this type of situation is there. The cyclone also cannot maintain its intensity to be weakened. So a high vertical wind shear is not favorable for cyclogenesis and intensification, and low vertical wind shear is favorable for genesis and intensification. Now, so same thing I have just explained here in the diagram. I'll just skip it.
Hello,
Yes.
sir.
Yes.
Extremely sorry, sir, to interfere you, sir. But due to
Please.
time,
How much time I have now?
sir, around 5 minutes. Sir.
Fine. I will complete it. Okay. So the cyclone moves. In a particular environment, just like a cork in the ocean. If I just throw a cork into the ocean, it will move along the ocean current. Similarly, in the atmosphere, a cyclone is just like a cork, and it moves as per the prevailing winds in the atmosphere. So similarly, the intensity of cyclone depends on many factors, just like the prevailing winds, the prevailing oceanic conditions and prevailing atmospheric conditions. According to the intensity is defined. So I will not discuss in details because of the shortage of time. I just want to say that there are many factors which determines the intensification and weakening of the cyclones. Now I'll come to the cyclone forecasting. As you know that the cyclone is a killer, as I have discussed so far. So therefore, for measuring its intensity and location and providing the correct forecast and take the mitigation measures, there are various steps. For disaster management, we have got hazard analysis, vulnerability analysis, preparedness and planning measures, the early warning and mitigation. But it has been seen that early warning is a major component. And when I say early warning, it includes the skill in monitoring and prediction of the cyclones, effective warning products generation disseminations, coordination with measuring, coordination with emergency response units like disaster managers, district collectors, then public perception. If people believe your warning, then they will act. So official warning should have the credibility. And luckily, over the years, with the technological investment, the warning has been quite accurate and people believe it, the estimates believe it, and hence they are acting upon it and they are taking the actions to minimize loss of lives. Now, in nutshell, the early warning system of cyclone consists of various steps. The first step is that you have to take observations from various platforms like surface observations, from automated weather stations, automated rain gauges, floating platform from the sea, by releasing balloons in the atmosphere, by following with the radar, and also by following the satellites. All these observations come to the forecaster to define what is the initial status of the atmosphere. And at the same time, it goes to the models to find out what will be the status in future time. So both these informations are available to the forecaster. Now he analyzes various types of forecast available from various types of models and various types of observations available from various weather systems. And finally, he takes a decision and provides this forecast, which is called as the end forecast. And this end forecast is provided in form of a bulletin. It is called a cyclone warning bulletin. It is given to decision maker, and decision maker takes the actions. We have got various types of models. You can see in this below diagram, there are various types of model forecast for a given cyclone file in here. Various track forecast is provided, and based on this track forecast, the forecaster decides what will be the final track, taking into decision the strength and weakness of various models, taking into decision the current status of the observations. And finally, on this day, the forecast was provided like this. For example, this is the final forecast. The black line is the actual track of the cyclone, and the red line is the forecast. So this, you will find that track, black and red line coinciding with each other 5 days in advance. So that has been the achievement because of the development of technology and investment in this sector. So accordingly, also we provide the rainfall forecast, wind forecast, and storm surge forecast. Okay, so these are the various types of observation systems I have just discussed. We have got observation systems with our actual observatories. We have got observation from satellite, observation from radar. All these observations are taken care while deciding the current location and intensity. Sometimes you might be hearing from TV that T number is 2.5 or T number is 5.5. The T stands for tropical cyclone intensity, and this intensity scale is defined based on the satellite imagery. But however, while giving the forecast, finally, the forecaster takes into consideration the intensity as estimated by the satellite, radar, all observations, and final forecast is provided. So there are various processes to determine the central intensity of the cyclones. I am not going to discuss. You can look into it afterwards. And we nowadays provide the forecast in 15 days in advance. Also. That is called an extended range forecast. You can see one example. We say 15 days in advance, where is the probable area where a cyclone can develop. Then after that, we follow it on day-to-day basis. 5 days in advance, we say where the cyclone will develop, what will be its intensification, what will be its track, where it will cross the coast, and accordingly, we provide the informations. So for this purpose, I'll just show an example of the cyclone funny. One of the model, how it is predicting long day before that cyclone crossed near Puri. On the left-hand side, we'll see that there are many tracks from different models. All these informations are utilized, and it was provided 3 days in advance. It was told that cyclone will cross Puri. Okay. So this is just an example of another cyclone. I'll just leave it. This is another example of cyclone forecast with the help of the tracks. And finally, this is just an example of finally what we say to the public. To the public, we say, this is the track of the cyclone. Red one is the track of the cyclone forecast. Black one is the actual track. On the right-hand side, we provide what will be the wind distribution, where will be the wind more than 120 kilometers, where will be the wind more than 90 kilometers, where the wind it will be more than say 30 kilometers. All these informations are provided to help the various marine community like fishermen, ships, trawlers, etc. And also disaster managers at the coast so that they can decide where to evacuate the people, where to keep the shelters, what action is to be taken to minimize the loss of lives and property. Okay, so these are some of the informations about the heavy rainfall, wind and storm surge forecast and warnings what we provide for different coasts. So we have also got modeling system to provide all these forecasts. This is just an example of storm surge forecast which is associated in association with INCOIS Hyderabad. We provide this forecast for different coasts. We say how much tidal water will inundate and up to what extent it will inundate, at what time it will inundate the low-lying areas of a particular district. Similarly, this is the rainfall forecast we provide for each river catchment, for each city, and for each district. For this purpose, also, we have got various types of models, and based on these models, we provide the final consensus forecast. We have got a very good decision support system to provide this type of forecast for the cyclones. This is an objective decision system where you can compare, comprehend, analyze all types of observations and forecast to reach out a decision and communicate to the public. So this is another example of what we did in case of the cyclones. I will tell you, once all this forecast is complete, we give this forecast to the general public through our cyclone warning centers. We have got 7 cyclone centers along the east and west coast. At the Delhi, we have got a cyclone warning division which coordinates with nationally and internationally. We'll be happy to know that we not only provide the cyclone forecast to India, but also all the countries in Bay of Bengal and Arabian Sea region. Delhi is one of the 6 regional centers in the world to provide the 13 countries in Bay of Bengal and Arabian Sea region. Okay, and these forecasts are provided to various groups in specific manner. For example, for the fishermen, we provide forecast in very common layman language. And for a port, we provide the fisher forecast in very technical manner as per their requirement. So there are about 13 types of forecast bulletins which are provided every 3 hours when a cyclone is approaching a coast. And all these forecast bulletins are provided in different stages called as pre-cyclone watch, cyclone alert, cyclone warning, and post-landfall outlook. The pre-cyclone watch is provided 72 hours in advance, cyclone alert 48 hours in advance, cyclone warning at least 24 hours in advance. In 12 hours before landfall, we issue post-landfall outlook indicating which interior districts also will be affected. And when we see that there will be no effect, we issue the DWARNING. So like this, we also issue, along with our forecast of the weather parameters, we also issue what is the damage expected in a particular district based on our forecast. And also we say what is the suggested action for the general public, for fishermen, for port, for shipping authorities, for the national highway authorities, for railway authorities, and for disaster managers and district collectors. So like this, for different stages of the cyclone, we have got different types of damage expectations and different stages of actions. So these information is also provided nowadays color coordinates like yellow, orange, and red code, and that is also given to the general public and disaster managers. So you'll be happy to know that unlike many countries, India has got a dedicated website for the cyclone purpose. And you'll be happy that 2.5 lakh people visit at a particular time to observe these cyclones. So with this, we'll find that we have come up also the new idea of social media. We utilize Facebook, Twitter, and WhatsApp also to provide the cyclone warning informations. We also got space-based information like games and Navic, and also utilize NAVTEC system for the shipping communities. And also we've got FM radio, community radio, and all types. What we see actually, we maintain some kind of redundancy in tropical cyclone warning system because it is a killer. It is a high-stake system. So therefore, we try to propagate the information using all means so that no person in the vulnerable area is left out to get the information. We are utilizing all the electronic gadgets available in latest manner to provide the information to the last mile and to the last person in the vulnerable region. So, but still there is scope to improve further. We are coming up with a lot of improvement with further understanding of the cyclone and with further investment in technology and further planning and preparatory measures to tackle the vagaries of the tropical cyclones. So thank you very much for listening to my talk with patience.
Thank you, sir. Thank you very much, sir, for your detailed presentation. The information provided by IMD is useful for general public to know about the weather forecast. It is very vital for the fishermen, for the civil aviation activities and farmers. IMD has high power radars and use satellite system also. IMD through its various activities certainly play a very significant role in creating awareness about the importance of climate and weather in life and economic of India. IMD has certainly played a very vital role in India. And like sir highlighted that the hazard risk mitigation is a very key to sustainable development. It has been government of and preparedness and mitigation. Keeping this in view, the government of India and pilot project, like sir mentioned, that the National Cyclone Risk Mitigation Project, NCRMP, that was being implemented through the World Bank assistance to reduce the impact of cyclone. And IMD is the nodal agency for forecasting cyclone in our country. The IMD has considerably increased its efforts in recent years in the areas of tropical cyclone forecasting and verification. And sir, just we have one question due to time constraint. The question is, sir, how can the education sector contribute in enhancing the cyclone risk reduction and resilience? How can education sector play a role in that?
Education sector plays a dominant role in the management of the cyclones. As all of us know, already in the textbooks of the schools, we have got the information about the tropical cyclones and its warning systems. Why it is so important? Because I'll tell you, if a child is aware about the tropical cyclones and its forecasting systems, it can propagate it to the entire family. And not only that, when a child goes out, he plays with other children and he communicates the society. He also communicates. As you know, the child also is a very good messenger, you can say, for propagating this information system. Not only that, the child also grows up and he also thinks about the system. He also gets ideas and opportunities, and he becomes scientifically strong to understand the phenomena, and also it gets inspiration to tackle this type of disasters. So therefore, it has got two objectives. One is to propagate the information to the larger mass base through the child. Other one is that through the child, you are imbibing a scientific culture. You are providing some kind of food of thought to the child to think about such kind of giant tropical weather systems, so that in the future, you can apply his knowledge, talent, expertise to tackle such type of disasters.
Thank you very much, sir. Thank you very much, sir. Now we will move on with our second presentation of the day. We have with us David Alexander, Risk and Disaster Reduction, Institute for Risk and Disaster Reduction at University College London. He has conducted research on disaster since 1980. His main focus of interest are emergency management and planning, earthquake science, disaster epidemiology, and theoretical issues in disaster risk reduction. He has also studied cascading disaster and disability and disaster. Alexander is visiting professor at the University of various universities in UK, Portugal, and Sweden, and also he is the research fellow at the Global Risk Forum in Switzerland. Professor David Alexander is the founder and editor-in-chief of Elsewhere International Journal of Disaster Risk Reduction. He is a member of the editorial board of 14 academic journals. In 2013, Alexander won the Distinguished Research Award of the International Society for Integrated Disaster Risk Management. Sir has penned more than 420 publications in the international repute, and it is our privilege to have you with us, sir. Over to you, sir.
Thank you very much. Let me start by sharing my screen, which I hope you can see.
Yes, sir.
You can see my PowerPoint, okay?
Yes, we can see your presentation.
Very good. Right. We're ready to start. So good afternoon and greetings from central Italy, where I currently am. My job now is to talk to you about the broader picture of disasters and their management and planning for emergencies, and also to give you some reflections on my 39 years and 10 months of studying these things. So I'm not specifically going to talk about COVID-19. I will, however, at the end, direct your attention to a fairly lengthy publication of mine, which you can download if you're interested in the relationship between COVID-19 and emergency planning and management. So, to look at the wider perspective, we really need to look at some of the things that connect with disasters. One of my messages today is that we cannot properly understand disasters unless we also understand the context in which they occur. And that means studying the other sources of human misery in their various forms and looking at, with foresight, what may happen in the future and what sort of challenges humanity will have to face at many levels, from the local to the global. Now, we have sort of renamed over the last 20 years the field as disaster risk reduction in order to make it more broadly all-embracing and to shift the emphasis from merely reacting to disasters to preparing for them, mitigating them, and generally encouraging resilience. But is this really what we are doing, or are we engaged in a process of disaster risk creation? Now, if you look at climate change, it is said that due to investment in fossil fuels, the creation of the problem receives about 1,000 times more funding than the measures to do something about it, because there are worldwide massive investments in fossil fuel exploration, exploitation, extraction, and so on. Now, I found on one occasion a publication that suggested that the cure to damage ratio for disasters is 1 to 43. In other words, that the world is spending about 43 times as much in creating the conditions for disasters to occur than it is in mitigating disaster. Now, I really can't comment on that because the source of that information did not explain its methodology, and I've not seen any subsequent follow-up to that. So this may in fact be inaccurate or untrue, but it is something that we can ponder. And there is no doubt that we live in an age in which we have a constant dialectic between factors that mitigate risk and factors that amplify risk. Humanity is constantly creating sources of risk at the same time as it is struggling to bring under control other sources of risk. The wild card in that is risk perception, which could go either way. Are we talking about perception of risk to the point that we wish to do something about it, reduce it? Or is risk perception something that we simply allow risk to occur or even welcome and embrace sources of risk? Of course, that is a highly complex question with many different answers around the world. But you can, for example, look at COVID, and you can see that there are risk takers and risk avoiders in the debate about what to do about coronavirus. And a very interesting dialectic develops between them as well. So, sorry, the screen has, there we go. Really, we need to develop the bigger picture. Pandemics are very definitely part of it, and it is worrying that a potential influenza virus has been discovered that could be the source of the next influenza pandemic. Influenza pandemics have a recurrence of somewhere between 35 and 40 years, but they occur irregularly, and so there is no real true cycle to that process. So pandemics and epidemics are clearly a very important part of human history and future human history, the future of human affairs. And that, of course, will have to be integrated with our knowledge of technological disasters, the effects of terrorism worldwide and locally, climate change and everything that it means in terms of climate extremes and climate change adaptation, And also, I think we found in the last 4 years or so that the world has passed a threshold, a tipping point, into which displacement and migration are going to be much more the rule than they were before. Not that they were ever absent from human affairs, but they are going to be very, very important in the future, and we will need to get used to them and deal with them. So, one thing to bear in mind here is that we need to, I think someone needs to mute a microphone. Thank you. Okay. We need to look at the root causes of disaster, and particularly at vulnerability. Disaster is not really caused by hazard, it is triggered by hazard, but vulnerability really is the chief explainer of disasters. But in order to understand them, we need to look at root causes and contexts in order to see how risk is generated and how hazard impacts then precipitate risk as disaster. So we will look at one or two examples to clarify that. But in some ways, you could look at that as a sort of egg model or egg hypothesis. To understand disaster properly, we need to look at the immediate causes, the prima facie causes. We need to look at the root causes. We need to look at the vulnerabilities that underlie the root causes, that are worked upon by the forces that create disaster, exploited by them. We need to look at the dynamic pressures that precipitate the immediate causes, but that alone is probably not enough. We need to look at general vulnerability and things like poverty, deprivation, marginalization, wealth differentials, the distribution of livelihoods, and so on. And these may be factors that don't directly affect the occurrence of disasters or the likelihood of disaster occurring, but they certainly do affect those factors in the general mode of things. In other words, in order to understand why disasters occur, where they will occur, and what to do about them, really we need to understand these other factors. And that occurred to me when I was thinking about floods in the United Kingdom. And there are, of course, various strategies and policies to deal with floods. But really, do they mean anything to someone who is, for example, homeless or jobless? Probably not. And very often disasters are merely one of the problems that one has to deal with in life. We therefore need to analyze disasters in order to understand them well in terms of the interaction between disaster vulnerability, which is to say people who are exposed to disaster, how vulnerable are they to death, injury, destruction, damage, loss of livelihood, interruption of activities, and so on. But how does that fit into their general vulnerability, for example, to losing their livelihoods or to having very low income or no income at all, and so on? And how does that fit into things like the general global economy on which we all depend, even at the local level? How does that fit into the landscape of risk, not merely disaster risk, but other forms of risk as well? There are plenty of places in the world where disasters are serious, even catastrophic, but they're not one of the major risks. Other risks may be more important: road accidents, disease, short lives, and so on. So this all calls into question a number of factors which have sort of been taken for granted since about 1648 AD. 1648 is, and 1629 are key dates because they are dates at which international diplomacy fixed peace, which gave shape to the form of modern nations, and even those nations that were in no way related to that process, the Peace of Westphalia and all of that, have nevertheless taken the model of nationhood from that. But the model of nationhood is very much called into question by globalization and by some of the global forces that are going on. Curiously, if you look up disasters and then look up the term welfare, you very rarely, if ever, find a definition of welfare. Why not? Surely it's not a difficult thing to define. Well, the answer is that it's politically not very expedient at all to define welfare, because if you define it, then you have to put it into action. And what we've seen in COVID has been that there has been a massive rise in welfare, often insufficient, but nevertheless a rise. because in fact, to keep society going at all, welfare is absolutely necessary. Identity is another. Modern identity only really has a history of a few hundred years. In some places, very much less. But identity is changing, and it's changing very, very rapidly at present. Entitlement, democracy. One thing that we tend to find is that more democratic society is, the better it is at managing disasters. And you can look at that in your own context by comparing different Indian states. If you find that in one state, the level of democracy you would regard as higher, then I think you'll find they're probably better at dealing with disasters. So, disaster, of course, is the fruit of that interaction between the hazards that cause the impact and the vulnerability that proliferates and propagates the impact, mitigated perhaps by resilience, the ability to withstand disaster. But what is most interesting about this, and what is one of the greatest challenges, is not to look at the individual systems. Can we manage disasters with technical systems? Do we have the right political decision making? Are we organized enough? What do the social systems tell us about ability to deal with disaster? No, the really interesting part is the interface between these systems. I've only managed to put 5 on the diagram for clarity, and of course there are others. Environmental systems are absolutely vitally important at present. It is the interface between these systems where the biggest challenges lie. So over time, we've generally gone ahead with what we might call the orthodox model that has lasted for the better part of 100 years. The physical event acts upon human vulnerability to give us the human consequences of disaster. In 1983, Kenneth Hewitt of Wilfrid Laurier University in Canada and many of his colleagues proposed what has sometimes been termed the radical critique. He said that human vulnerability is essentially the key to and the essence of disaster. The physical event merely triggers it. If you want to understand disaster, then you must look at human vulnerability first and foremost to understand the human consequences. But I think we now need a model something like this. We need to look at the context, the consequences of disaster as a plexus of factors that act upon human vulnerability to give us the human consequences. Physical events are in there, but culture and history as well have to be taken into account because they pose both opportunities and limitations regarding what we can achieve. So, pardon me, here is a model of vulnerability to disaster. It's the MOVE model, and MOVE was a European project for estimating and understanding vulnerability to disasters and climate change in Europe. And in that project, we looked very carefully at how we could divide up the various factors and put them together in some meaningful relationship. And this is a simplified version of it. There are, however, risks associated with using this sort of formulation. One of those is that we're actually dealing with a holistic phenomenon, vulnerability, which has physical, environmental, social, economic, etc. sides to it, but very often we cannot separate them out, and we shouldn't even try to. Plus, we also need to add context to this model. But vulnerability can be looked at in an entirely different way. Sometimes it's counterproductive to look at it in terms of economic vulnerability, physical vulnerability, psychological vulnerability, but instead to look at it in terms of process. For example, in total vulnerability, life is generally precarious for people who simply have no defenses against disaster. Perhaps, however, the principal factors are economic. In other words, that livelihoods are the key to surviving disaster, and they are the most vulnerable part of the equation. Or could it be that the riskiness of technology leads us to disaster? Or what about where corruption prevails, where negligence prevails, where political decision-making is simply inadequate, where bribery and where siphoning off of funds and so on and so forth really undermine any attempt to get disaster under control, and so on. But what is resilience? since about 1981, and particularly since the early 2000s, much emphasis has been placed on trying to generate, develop, and emplace resilience. But is it an objective? Is it a process? Is it a strategy? Is it a paradigm? Or is it in fact more than one paradigm? Is it a question of restoring things to how they were before disaster struck? Or is it not bounce back at all, but bounce forward to a state of greater readiness and greater ability to resist disaster? At what scale should we apply resilience? Is it something you can do internationally? Or is it a merely local thing? Is it really best to focus on the community scale? But what is community? And what scale does it operate at? Community is often mentioned, but the trouble with it is it can apply at almost any scale. I have a community of people I work with all over the world. We're in completely different places and time zones, and that too is a community. But of course, we also have street corner communities at the local scale. And can resilience reconcile dynamic and static elements of disasters and disaster prevention and mitigation? So, one of the problems of resilience as a concept is that it has been overcomplicated. I personally prefer a simple view of it, which is derived from 19th century views of mechanics, in which a material, when tested, perhaps clay or steel or wood, would have both brittle strength and the ability to bend, ductility. By analogy, society needs to have an optimum combination of resistance to disasters, in other words, hardening or hardness, and ability to adapt to the threat of disasters, in other words, to avoid or to mitigate the effects when they occur, if they cannot be avoided. And that really is a simple view of resilience, and I think that it can be counterproductive to try to complicate it more. But nevertheless, resilience does sit at the center of a whole variety of different things that go on and different views and fields. It has to interact in disaster terms with climate change adaptation, sustainability and the science behind that, and of course, managing all forms of other hazard and risk, everything from criminal activity to disease, and so on and so forth. So resilience is very definitely multifaceted. So we need to somehow balance our approach to vulnerability and to resilience, which means that we need to utilize to the best advantage our knowledge of vulnerability, as well as the threats and risks that it engenders. We need to utilize our current knowledge about the concept of resilience and how to apply it in the practical ways and at the local and practical levels where it needs to be applied. We need to study the human organization in crisis situations, and this is very interesting to study in the context of COVID-19, not the least because it's highly variable from one place to another, from one country to another, but very often from one region to another within a country, if not from one town to another. And we can see highly varied results from that. And there are many lessons. We need a gap analysis. Where are we not doing enough? We need a resilience matrix. What do we need to achieve? And how do we need to weave together the different elements of resilience in order to make something holistic that will work? We need to look at the interactions between vulnerability and resilience. And in that, we need a theoretical model. And that's what I'm going to try and provide to you. Let's look at cascading disasters. And why cascading disasters? Well, the answer is that in the view of myself and my research group, virtually all disasters, unless they're very, very small and very, very simple, will be cascading events. And one reason for that is that we live in network societies. Even those where there is very little money and very few resources are network societies. We find, for example, that cattle herders in Southern Africa depend upon mobile telephones, and that is part of the networked world. So cascading disasters, what are they? Well, we firstly could think of them in simple terms according to the toppling dominoes idea, knock-on effects. One thing leads to another, leads to another, leads to another. That's the simple view. But also it's a question of linking the realities in the both physical and social domains. In other words, we have physical impacts, but they have a variety, a spread, a chain, and a network of social repercussions. Then we have compound and interconnected risks. In other words, one risk can trigger another. It may be that the triggering risk, the initial risk, is not the important one. It may be that other risks are more important. Even in COVID, we're definitely seeing this as there is that delicate balancing mechanism between the socioeconomic disaster and the health and medical disaster. And that really is the mother of all cascading events. We see nonlinear progress of cascading disasters, and we see risks that are amplified by vulnerabilities that come into play. And we see this happening at multiple scales with the activation of secondary risks. And one way that we can look at this is that very often the key is electricity. Now, you've probably heard of blue sky thinking. In other words, you look at the blue sky and you think very creatively and very freely. Well, my research group does a great deal of black sky thinking. What to do when the lights go out. A picture here of Venezuela, it suffered considerable power outages and had to adapt to them. But they've also occurred in all sorts of places. For example, two examples here in the United States, Eastern Seaboard. Large areas as a result of grid failures with no electrical power. But what does that mean? Does it simply mean that you can't use your computer and eventually you can't use your telephone? Or does it mean more than that? Does it mean your life is in danger? So in fact, electricity failure among somewhere between 8 and 11 major categories of critical infrastructure is really the key to the others, because electricity is involved in all of these. For example, it pumps water and sewerage. It is essential to communications, which nowadays are largely governed by electronics. Food toxicity results from the failure of refrigeration. Banking is heavily dependent on electricity, if not totally dependent on it. The food and fuel supply are both dependent on electricity. For example, fuel is electrically pumped, and much transportation is dependent on electricity one way or another. So in fact, social factors are also heavily dependent on the supply of electricity. Can we really rely on it? Electricity failure is quite common in India, but it's quite common in many other parts of the world, rich and poor. Now, if we look also at the triple disaster in Japan, earthquake, tsunami, and nuclear release, and the subsequent 9 years of recovery, and one of the most complex and challenging recovery problems in the world, that also is a major cascading event in many respects. For example, I have twice been to Fukushima Daiichi and stood in the middle of that photograph with radiation beaming at me at the rate of about 350 chest x-rays. And it is awesome. But the nuclear release from 4 reactors at Fukushima Daiichi effectively destroyed a relationship of trust between the Japanese people, their government, and scientists. And it has taken 9 years of painstaking work to try to restore that trust. But trust is essential in disaster risk reduction. If we look at the case of Eyjafjallajökull, it was a minor Icelandic volcano. But in April 2010, it erupted to the point where we had volcanic ash in the stratosphere over more than 70% of Europe, which shut down 70% of Europe's airports. Here are the major airports, and few of them were open. Some were shut for a week. And that meant that 8.5 million people were stranded. It also meant that commerce shut down wherever air travel was implicated. It was a rather difficult situation with tremendous imbalances in normal life, but it was a short-term one. One thing to bear in mind about this is that there are much larger Icelandic volcanoes that could cover Europe and beyond with very much more volcanic ash for very much longer periods of time. But of course, since then, we've seen a ground stop in civil aviation and a radical reorganization of the whole industry as a result of COVID and people's reluctance to fly, or in fact, the closure of national borders. But we can also apply cascading principles to much smaller events. For example, in 2017, this 24-story residential building burnt in London with the loss of 72 lives. And there is now an inquiry which is sitting as I speak into this. And this has become a national cause célèbre. And if you look at it, what you find is that it has many different elements to it, many different aspects. And I would say that really the cause of this disaster is not the flammability of the cladding of the building, the fact that it caught fire. There you can see a piece of the cladding on fire falling off the building. That was the immediate cause. But in fact, the real cause was ideological. It was the decimation of building regulations and the inspection regime that went with them. But then the disaster propagated because, although it says here 314 dangerous residential towers were found to exist in the United Kingdom, the answer is actually 511. In fact, more were discovered subsequently. So we have a situation of extreme risk all over the country in buildings of this kind. And we currently have a fight over the question of who is responsible for that. And that is one of the propagating, cascading effects of this disaster. Others include dangerous urban pollution of soil and air, and ongoing issues with welfare and equity. Who pays for this? Who houses the people left homeless by it? Whose fault is it? Who accepts responsibility for it? And so on. These are all part of the cascade. And it is perhaps an illustration of how you could use the idea of a triggering event and then a cascade through the critical infrastructure and through the relations between different kinds of vulnerability, which, of course, can have a whole variety of different effects, some of which may well be worse than the triggering event itself. In fact, in the UK, even if we look merely at that one residential fire, there have been several tall building fires since then that could well have had a higher death toll had they occurred at different times of day. So the simple model then, on the left, part A, is the toppling dominoes idea of one effect leading to another, leading to another. For example, you have high rainfall, it leads to high river discharge, it leads to overtopping of a reservoir dam, it leads to the beginnings of flood downstream, it leads to the potential collapse of the dam, it leads to the need for evacuation, it leads to questions of how to look after the evacuees, it leads to damage to agriculture, it leads to loss of revenue and livelihood and accommodation, and so on and so forth. But you can also have escalation points. It's one of the key issues in cascading disasters, the escalation point where the interaction of vulnerabilities can increase the power of the event, the destructive power, to create disasters, and can lead to new directions of propagation of the cascade. And that is the result of the interaction of different kinds of vulnerability. For example, in COVID, we've seen huge increases in the demand for mental health services. That's one issue, for example. We've had a huge increase in mental dis-ease, mental problems as a result of lockdown, loss of livelihood, and all the things that go with this pandemic. So in fact, there are many different ways in which vulnerabilities can interact to increase the power of disaster. And that's what we need to study, especially in emergency planning. Look at where the things interact in order to know what to plan for. We also need to look at the ways that different risks interact. For example, we have NATEX, in other words, natural events that trigger technological disasters, such as toxic spills or explosions. And we've had a number of events where, for example, floods have entered factories and caused fires, explosions, and toxic clouds. That is a simple example of an ATEC of the interaction between different kinds of risks. We also need to look very carefully at environmental drivers of interacting risk and how they too can lead to cascades. So what is risk in terms of its disaster potential? Well, compounded risk, where we have multiple extreme events. That, of course, we saw with the earthquake and tsunami in Japan and a variety of other places too. interacting risk, where we have environmental problems that interact with disaster potential, interconnected risk, where the natural, human, and technological systems interact. One thing about COVID, by the way, is that we knew the scenario for COVID from the period 2003 to 2009 when it was put together. In fact, we had a perfectly good idea of what was going to happen. In fact, I taught it for 11 years before it did happen, not because I'm particularly clever, but simply because I've read the literature. So that enabled us to know that, in fact, a pandemic is something where you've got both the medical side and the socioeconomic side, and you cannot easily say that the medical side is worse than the socioeconomic, or vice versa. And of course, we have cascading risk, where tightly coupled systems propagate through critical infrastructure, and perhaps some combination of all of this. Don't forget coronal mass ejections, space weather, and you can get onto the internet and get today's space weather forecast. Why is this important? Well, in fact, a coronal mass ejection or sunspot can give you a situation 15 to 18 hours later where we have potentially large damage to communications and global navigation satellites, where we have loss of electricity on a wide and large scale. And in the case of a so-called Carrington event, which is a very large collection of sunspots, then we could easily have trillions of dollars of damage. And if you think that's unlikely, one of these narrowly missed the Earth in 2012. The last one to hit it was 1859. But in prehistoric times, there was such an event 10 times larger. So in point of fact, geoelectrical currents, geomagnetic currents, and plasma in the Earth's atmosphere can cause very considerable damage to electrical systems. When I say damage to transformers, I mean transformers the size of a room. They're actually made in India and they take a year to make. And hence, this could lead to very long interruptions to electricity with all the cascading effects that occurs. So, in fact, a Carrington event could be quite a serious thing to be concerned about and to be ready for. So, here's a magnitude scale for cascading events. Perhaps the Japanese earthquake, tsunami, and nuclear release is an M5. But you can, in planning, compare events on the basis of their magnitude and use these in creating scenarios for cascades so that by planning for emergencies, you can look for the events and the consequences and the interactions that you need to plan for and would otherwise forget. So do not focus only on the trigger of an event, for example, heavy rainfall or a cyclone. Yes, you need to understand those, of course, but look at the strategic and tactical levels of what to do about the consequences. Look at the different fields: psychology, sociology, architecture, engineering, geology, meteorology, and how they fit together. Look at the way that policies and plans could be induced, modified to take account of possible cascades. Broaden the impact analysis. Look at different kinds of impact. Look at them in a comparative way to see which is more important. Use impact trees. What leads from one thing to another? Identify escalation points. Where are you going to get interactions that worsen the situation? And what is going to be most important? What do you really have to worry about? And then you can subject these to stress tests, which are perhaps merely theoretical ways of working through the scenario to say, well, what's going to happen if we take the last great cyclone and apply it to a set of conditions? What actually comes out of this? And things like that. And the world is changing dynamically all the time, so you need to keep doing this. What was valid yesterday won't be entirely valid tomorrow, which is why it must be redone. Now, a quick word about the Sendai framework. It's what we all tend to work by, but it is very much a top-down sort of approach. I'm rather skeptical about it. It's a non-binding agreement. Does it really lead to action? It can enable unscrupulous politicians to be legitimized at home and abroad, and there's plenty of evidence of that, although I'd prefer to remain neutral right now and not cite it. And perhaps disaster risk reduction isn't really a top-down process. the theatre of operations in any disaster, for example, the Indian Ocean tsunami, 13 nations involved, but it was still a local affair. If you cannot manage it at the level of fishing villages, tourist resorts, coastal communities, you can't manage it at all. So is disaster risk reduction top down? You can harmonise it from above, but you have to do it locally. And the UN processes do tend to use evidence rather selectively. And although they try hard to encourage accountability, is it really there? Now, at the local level, of course, there is the Safe Cities Initiative, a 10-point action plan. It gets together the mayors of cities that have signed up to it, and they can exchange information, and that's a very good thing. The background, by the way, shows Bogota in Colombia. Field assessment and implementation of the 10-point action plan are emphasized, and that's good. You can sign up for this initiative, but only about 1% of urban areas around the world have actually signed up to it. But it does at least throw emphasis on things like safe schools and safe health facilities, both of which are absolutely vital and essential. So it does have its good points. But on the other hand, take the case of Venice, which was adopted as a role model. Well, is it a role model? It's certainly got a good publicity department, but this is Venice on an ordinary day. Does that look safe to you? It's a real picture. That happens twice a day in Venice. They haven't managed to ban cruise ships. Actually, it probably doesn't happen now because nobody's taking cruises during the pandemic. But until the pandemic, this was happening twice a day and highly dangerous too. If one of these misnavigates, then you could have huge oil spills, you could have great damage, and you could have a listing ship in the middle of one of the most fragile and valuable urban areas in the world. And that is not my idea of resilience. So questions about the Sendai framework. Do we really need it, first and foremost? Well, there are justifications for it, and we certainly need international collaboration. So perhaps we do. But will it have an impact? Is it reducing losses? And that really is a very debatable question. I don't have the answer. And are there alternatives? Are there better alternatives? Is it all better done at the local level and aggregated upwards? Who will hold governments to account? The UN can't do it. It does not have the mandate. On the other hand, we can try and shame governments. And have we got the right wording? The wording was achieved very painfully by about 87 different countries actively negotiating overnight until the very last moment. And in many cases, trying to wriggle out of their obligation to their own citizens. And can such a document ever be anything but top-down? Does it matter that it's only top-down? Well, I think it does matter, actually. And you can take any official document, pardon me, and you can look at it using a search engine to see how many times the word should appears. And you can make the should ratio, the number of shoulds per page, is 0.38 in the Sendai framework, which is not bad. But the word should appears 21 times. Well, we all should. We should do many different things. I should be doing things that I haven't done. But we need to replace the word should with will, shall, and must. Above all, with must. Governments must do the following, not they should do the following. And really, do targets have any meaning if we're still creating the conditions for disasters, especially in the wealth differential where the rich get richer and the rich are likely by 2030 to command and control 2/3 of the world's wealth if things don't change. And that has enormous implications for the control of diseases and disaster. Science, for whom is it? And who decides for whom it is? Is science really for the poor and the dispossessed? Does it help them? How can we make it help them? Does the Sendai framework enable science to help people? And what frameworks will produce results when governments are corrupt or unethical? And there are plenty of unethical, corrupt governments around the world, or degrees of corruption. And if it's all applied at the national level, is the national level still the best level to do things? Does national policy really matter? And that, of course, is particularly relevant in any kind of federal republic, such as India, Germany, the United States, or so on. Perhaps instead there are other levels where things are best done. One thing I found about COVID is that it seems to be best managed where the management is not nationally coordinated, well, coordinated perhaps, but it's not done nationally, it's devolved to the regional level. Although this can lead to startling variations in the ability to manage regionally. And so really, is a top-down culture healthy or unhealthy? And those are all questions that can be debated. I certainly wouldn't wish to propose absolute answers to any of them, but there's certainly things you can think about. And sometimes merely thinking it through is better than having an outright answer. So to conclude, some issues for disaster risk reduction. Somehow we have to bridge the wealth gap. We cannot afford, in a world that has 87 tax havens, $9 trillion worth of wealth, which are simply stored away in them, and massive need, an increasing need worldwide. The world has missed its goals on poverty reduction and environmental protection, and that really is not good. So we have the wrong kind of globalization. Globalization itself is not inherently wrong, and indeed the best thing you can do is learn from other countries, other situations, other parts of the world, rich and poor. But we don't need the kind of globalization that leads to exploitation, extraction of wealth, and impoverishment, marginalization. Gender is absolutely fundamental. It is the key to very, very many things here. And so that is something that needs to be addressed every time and in every single context. Power structures, likewise, human rights, where human rights are in any way curtailed, it curtails the access to information and the ability to act to reduce disaster risk. So does corruption. We have that uneasy dialogue or duality between military aid and humanitarian aid. Can we swing the balance towards the latter? We've had consensuses around the world, but are they disintegrating in these times of identity politics? And that is a contextual factor of enormous importance. Well, really, I've asked the questions, I haven't given the answer, so perhaps I should end by apologizing. But from the website of my university and my institute, you can download this report on how to look at the scenario for COVID and derive lessons of it from it for emergency planning and emergency management, perhaps for future pandemics, if not for the rest of the present one. And it was an attempt to codify that. Nothing very novel about it, but it is at least a systematic approach. You can also find some essays on my blog spot, there, emergency-planning, and about 124 different presentations in languages on SlideShare at the address at the bottom here. So thank you very much for listening, and that is the end of my presentation.
Thank you very much, sir, for your...
It's a pleasure.
Rightly underline the need to balance the vulnerability and resilience. Resilience is indeed a multifaceted and refer to the ability of individuals or the societies or the socio-economic system to cope with the sudden impact of crisis and disaster. And we have to come up with innovative solutions, like sir has mentioned, to manage the cascading disaster risk, like investing in complex risk scenario planning or supported by the seismic risk assessment for multi-hazard, or promotion of disaster risk reduction measures as a public good, or building the financial resilience through seeking like risk financing, insurance, or risk transfer. And also like we have to build a culture of regional or social innovation approaches for disaster risk reduction together. And also as I highlighted, there is a, like we have to deepen the regional cooperation for integrated disaster early warning system, or and to enhance the reduction in disaster. Thank you very much, sir. And we have one question, sir, from one of our participants, like how developed nations, how they have worked towards reducing the impact of disaster in the last 2 decades that the developing countries are lacking, and that needs to be learned from the developed countries.
Yes, that really can't be answered very well, because developing countries differ enormously in their ability to manage disaster, in what they've done in their history and in their administrative, political and cultural aspects. So really there is no short answer to that, but what you can do are look at the instances around the world where developing countries, even very poor countries or countries with very poor situations, have done well at managing disaster. And really the first thing you can do is look at organization. Those countries that manage to organize, regardless of how wealthy they are, tend to do better. And the reason is that you really have to be able to use the resources you've got. Now, they may be completely insufficient, but whatever you have got, you should be using to your best abilities, which means that you need to democratize the whole process of managing disasters. And some countries have done pretty well at that, despite having rather poor distribution of resources or access to resources, and other countries less so. But if you do that, if you bring it to the local level and put it in the hands of the stakeholders, namely the people whose lives and livelihoods are threatened by disaster, and you give them as much knowledge and expertise as you can, then regardless of the shortage of resources, much can be done. Bangladesh is a very good instance here, where it's not perfect, but nowhere is. Not even the richest countries are perfect at this, but in Bangladesh, they have most certainly taken the scientific information, and there are many instances where they've become very interested in the social reaction, the economic reaction, and done research into how people react to disasters that they can then feed back into the process and get local people involved in managing their own risks. You see it in the Andes in places like Peru and Ecuador. And although at the national level, things may be going pretty badly, there are plenty of places at the local level where, despite all of the setbacks, the challenges and the hazards, they've got together and they've done things. For example, in one instance in Peru, a local community, very isolated, deep in the mountains, managed to set up a landslide warning system, because they have very fast, very dangerous, very lethal landslides, and base it on the local newsagents, which is a small shop selling very few things, but there the local community gravitates for its landslide information. They have people out watching the situation. They know what to look for. They have a good idea about what landslides are, what they do, where they can occur. They've all derived that from local information and local organization. So in fact, there's a lot that you can do at the local level. And with access to the internet, there's a huge amount you can learn from different places and different circumstances and adapt to your own. But it has to be done democratically. The big challenge of the 21st century is to get people involved in managing their own risks to a much greater extent than previously.
Thank you very much, sir. Thank you for your response, sir. And sir, it was a very big opportunity for me, because throughout my PhD work, I have referred your articles, your research paper. It was a very big opportunity for me also to listen to your lecture one-to-one. Thank you very much.
It's a pleasure to be here. So thank you so much.
Yes. And now moving on with our presentation. For our last presentation of the day, we have Professor Ghosh from IIT Jammu. Prior to working in IIT Jammu, Professor Ghosh has also worked with various prestigious institutions of India, namely NIDM, National Institute of Disaster Management, BHU, University of Tsukuba in Japan. We are also very fortunate to have you, sir, with us here. And now I will pass on the stage to you, sir. Over to you. Sir, yes, sir.
Yeah. Mute, and then part is not, your content is not coming.
Now, sir, it will be able to.
Now it has come.
Yes, sir.
Okay. So it is, in fact, I'm in NIDM itself. I'm on deputation here for more than a year. So that way our bond and our sharing and always ethos and togetherness is always there. I'm, of course, a special thanks to Professor Surya Prakash and our ED and IDM and all the luminaries that who have been involved here and considered that this disaster resilient infrastructure is one of the item that which is being given to me after listening to wonderful descriptions about wonderful lectures from Professor David. And I think presenting something in this form, especially about the disaster resilient infrastructure, I will simply show some of the photographs. Through that, I will describe whatever extent that it is possible. Okay, and when we see that disaster resilient infrastructure, is my screen is fully seen?
It's
one interference is there, small. What happened? What is this? Okay, now it is okay. Okay. Okay, thank you. I just simply go through the disaster resilient infrastructure with some of the solutions that we can come up where various materials are being used. So in this case, I will use that this example over here, the road got severely affected in this manner. In fact, we in civil engineering, we do not know the below this star, what is how this virgin soil in the road making are affected due to earthquake. We don't have any code or any regulations or anything, no design. We only look after top 1 meter, 1.5 meter only. So earthquake occurs, roads are constructed, and we do not know anything underground except that soil profile only, which is existing, and we make the road here by roller and series of chart and which are available in our civil engineering, transportation engineering. But when it is severed like this by earthquake, we have not yet made any such code or any such graph or anything to design these things. But whenever such kind of materials are being used, synthetic materials are being used, we can give some kind of flexibility, assurity that to the road or many other infrastructure, which I would like to show you one by one, that they can give some life that which is friendly, or rather I would say that which are able to tolerate the severity of damages that which is being seen over here. But one thing that side by side, another photo that is showing, it is in Japan, that which the road is brought back to this condition in 6 days after 2011 tsunami-genic earthquake that happened in Japan. So bringing it back to the normal condition is the resilience that within a gap of 6 days. And we also in our country have got a lot of such measures, especially in the hill area. Whenever landslides occur, then our agencies are there, Border Roads Organization, PWD, and many are equipped with removing the debris and make the road operational maybe a few hours or few minutes or few days of time, depending on the gigantic nature of the events and disaster that we face in. So, so we use many such kind of new materials in the last 2-3 decades to make more resilience to our road infrastructure, for one example that I would like to take. Now let us see that. Oh, in fact, this is the aerial view of the transit campus that in the main campus itself of IIT Jammu. You are most welcome, and this is the road going towards Srinagar, which is about 255 kilometers from here. It is a National Highway 44, and 30 kilometers is the distance from here to Mata Vaishno Devi. So today's context, I would say that in disaster, power gets severed, communication that is got severed. We have more than maybe 10 lakh of mobile towers in the country where it needs a lot of power to keep the mobile communication on. But in order to, and several thousands of mobile tower communications are being, supplied power with a diesel generator. And in most of the time, that using diesel and getting power and keeping the mobile tower on, which is essential in the life that we are dealing with. But how to make an alternative storage of power, especially during disaster, or keeping communication alive. I will give a glimpse of that in the next slide. So one thing is this. Then I will show some of the live examples, which is being done living with disaster. It may be cyclone, it may be thunderbolt, it may be urban flood, it may be landslide, it may be earthquake, and what are the nature-based solutions? I'm going to give some of these things which are not involving much of the foreign technology or anything. What are the nature has given us where we are able to recognize their importance in solving many of the disaster in the name of disaster resilience. That I will show based solution and some technology-based solutions where those can be adopted more and more comprehensively to make our infrastructure disaster resilient. And at the end, I will show that what are the auditing of the current infrastructure and what are those few simple methods. I will only give a glimpse of that. So let me see that what happens. Millions of scenarios are there. I'm not giving any description, but each type of disaster is different. Each one is different. This one is different in a cyclone-prone area. So we know that what are the kind of resiliency that we should provide into the buildings or habitat near the cyclone-prone area. We don't know that, but that has to be translated into the real practice. So for that, many guidelines projects are going on, and hope that in the years to come, in the decade that we have till 2030, a lot of things are systematically being adopted and being achieved, and attention of the academia research are being drawn into through such kind of interaction. So only thing that the first part, solar industry, if you see the Google or if you go through that, you'll see the price, whatever panel that available in few hundred rupees to few thousand rupees per megawatt, or you can see that acres and kilometers of land are being horizontally being occupied or in some slant manner with different angle, or in the rooftop, or even on the canal top. We are using plenty of this kind of robust solar panel. But think of that in the cyclone-prone area, or in a disaster or desert area, or even in the Leh-Ladakh area where snowfalls are. There are many places in the Himalayan where snowfalls and blizzards takes place, where sunrise is only for 8 hours, 7 hours, or during rainy season, then efficiency as well as timing, there are lots of limitation. So in the solar industry, which is not continuous because in the night it is not available. Main part I'm going to highlight over here, storage is a problem, but what is a solution has come up recently where pilot battery is going to be made, not lithium-ion battery. It has some limitation, life cycle, which is hardly 5 years, 7 years. Still, hundreds of researchers working diligently in the laboratory to go for an alternative to storage of power, much beyond that what lithium ion is able to do. So what we have proposed here for Leh-Ladakh area on behalf of IIT Jammu, that I'm going to show you one of the slide where 1 megawatt battery storage device with continuous heating of the extra heat is going to be used for cooling, heating water in a Leh-Ladakh type of area. That I'm going to show you. But one thing is, when such kind of things, life cycle is also limited, cost is also 2-3 times higher, and then efficiency of the solar cell also, it has reached to the bottom. So we do not have much hope in going in the same technology. So in that case, and not only that, when such kind of panels are there in Orissa or even in, cyclone prone like in the Fani or in this area, that our airport and their topmost panels are being blown away with a speed more than 150 or 200 kilometers. So in that case, if it is in the desert area, then sand dunes or sand storms will be there. It will cover the entire thing. So keeping and maintaining their efficiency in the current context is a big hurdle for us. Entire globe we are facing that. So how to take care of life cycle, extra life cycle, and how to make a storage of this solar power, not the ordinary battery or currently that which is being emphasized in the lithium-ion battery. That I'm going to show you where three technologies are made together. These are the foldable solar panel, which is a retractable smart solar panel, which will be used. And then when with the weather sensitivity is there, this is a mechanical simulation can be made over there. Solar, these are even up to 50 meters, 60 meters on both sides, and they are retractable. They can be cleaned as well as brought here in this. They can be rolled and they can be brought here with the all mechanical system. Arrangement has been made that this will act as a fit to the battery, which is size of my office table only. This is the only battery which is hardly 5 feet by 7 feet. My office table battery size, which needs some input as storage of the energy. In the daytime, like there are as many as 14 hours of sunlight in Leh. So in daytime, this will provide as an input, and in 24 hours, this is also retractable, smart. You see the thing, smart wind turbine, which will give the energy and which is being stored over here, where battery storage is 1 megawatt or even higher. And life cycle is even 25 years and more, which is developed recently in Griffith University by a company, Yes Antra, and pilot to be ready by February 2021. And of course, I'm giving this presentation with the credit to Dr. Vijay K. Madali, who has developed this technology. And I know that throughout the world, more than 100 such research groups, including India, they are working on the development of robust energy storage to the capacity of 1 megawatt hour, which can supply uninterrupted power for even 30 to 40 days together. So in such cases, this is a registered company in Chennai and patent already filed internationally and nationally. So as far as keeping the supply of electricity into our vital installation, even in our offices or even in the factories, 1 megawatt or even higher such kind of storage is the first time that have come into the market. Market, of course, subject to, pilot is going to be ready by February. So this is what just I wanted to show. And in fact, these are the series of panel together, three technologies together, we can feed into their battery, and even solar wind panel also is there. Together, it becomes a complete package which is recently presented to Leh and Honorable LG to adopt this one, and portable wind power even up to kilowatt hour. Everything can be packed, and weather sensitivity and smartness is there, that whenever dust storm will be there or blizzard will be there, they have the sensor and they will save the things, and when it will pack into that through its mechanical and gear and auto gear devices with sensor, it will completely clean. So auto cleaning is there, and battery life is 25 years, and whereas portable solar can have 150 kilowatt capacity with auto cleaning and foldable during wind or dust storm. So some of the thing, and inclement weather, like if it is in the coastal area, we know 2 days, 3 days before the cyclone is coming. So such kind of installation, rather than rooftop one that which we are familiar with these days, now this will find the way and means to enter into our community services during disaster, or even taking our life more comfortably with the kind of system that which is developed, which will work in many of the facilities that you can think of. Okay. Now let me come back to because that is one part that where new developments are taken. But now let me come back to one of the things while I was in NIDM, that Indian Parliament started questions on 22nd November. I'm not mentioning the number, which you can check it there. Whether our infrastructures are vulnerable to impending hazards. One-liner answer is not possible. And within 2 hours, we cannot make this kind of answers. Economics of disaster, scientific or unscientific. I know that here, all stalwarts, especially academics from the universities and practical practice and disaster management fraternity who are, in this group now,